So we're going 1, 1, 1, 1, 1, 1, minus 1, 1. I mean, the good thing is that we have a fourth element, our W coordinate, and 1 generally. These look reasonable. So this is interesting. New standard on. Note yay, nice little crash on the graphics card again. Someday I'm going to figure out what's causing that. I suspect it might be OBS combined with loading it a little bit, but I'm not entirely sure. So, problem might be in the buffer data part here, because I vaguely remember there's something special, possible, no, that should be about right. That should be the number of floats, or that should be the size of it, and that should be the data. And then this is number of elements. Oh, this might actually be a little bit on the low side. Let's just quickly take a look at the chunk render to see what I'm doing here. Yeah, because I'm using size of vertex data, so that's the total size of all my vertex data. So here, that's that coordinate, yeah, that one. I kind of need to multiply that by the size of a geo float. Let's try that again then. So now it's definitely rendering it. That's a good thing. Now we just need it to stay around the player. And this is where it becomes a little bit interesting. Because what we are going to do for once is that we are actually going to set these as 0, because that way they do not get affected by translation. But that also means that they are going to be at coordinate 0 when we go through it, and this is where we want to set our, for the W coordinate is going to be 0, because we've just multiplied 0 by 1, and that means it's going to be right up close to us, which is not what we want. So we're going to set it to 1 and hope that that means it's far, far away. So we're just going to clean and rebuild. That's a small skybox. Hopefully this will make it a little bit bigger. And we're done linking. Well, at least I'm sort of an expert at getting it to render in weird and wonderful ways. But you'll see it's not moving relative to me as a player, so that's a good start. And to some degree, stuff is rendering on top of it. That is quite interesting. I'm going to try and put these back at 1. See what that does. Well, we lost that relatively quickly. Okay. So we're still setting the W coordinate to 1. Am I memorizing this wrong? Should it be 0? With 1 being like the closest, 0 being the furthest away. Oh, and while we are rendering this, I just want to set the GL depth function to be GL less or equal, so that even though we've set the depth buffer to 0, we're still going to draw on top of it. Let's try that. Yeah, that was not a hit. Now, of course, I'm making the mistake of doing 2 changes at the same time, which always makes it difficult to determine what's going on. We're just going to try and set that back to 1. And switch over again. Definitely weird. So we're not going to do that. And for our skybox render, we have ones all around here. So now we're back sort of. So we have ones over here, and we're not going to set the W coordinate to 1 anymore. I'm going to try and see that again. Okay, done linking. Gonna switch over here. So we have that nice little cube there, and it's actually, I mean, as a skybox, it works. Now, the question is, how do we get it to actually, I mean, the nice thing would be to start by getting it to stay around the player. So, thing is, you can see when I'm switching from one chunk to another, it moves, and that's because it's only using the, I have no idea where there it is. So as it moves like this, that's because it's not respecting the model transform, but it's still respecting the translation in our camera, which is part of our view transform. And the first thing we need to do is remove that. So removing that, I guess the easiest way to do that would be to say that I would like to have a, yeah, if we trying to think here, which is a little bit difficult apparently. Thing is that the view transform also includes the perspective transform. And that's a little bit nasty. So when we're, let's switch over here. So when we are doing our camera here, we have a projection transform, and we have a, which we start with, and then we add our camera on top of that projection transform, and we return that as a combined projection and view transform. So we would like to have, and the thing is that this projection transform uses the W coordinate to create our projection, or not our projection. Yeah, it uses the W coordinate of the vector to create our projection, but it also uses that same to do our translation. So we'd like to sort of ignore this last bit of translation, yet still keep our projection. The question is, do we need to split it up? Which might be a possibility. Or can we get around it by doing something sneaky? Because the idea of placing everything at the back is not a matter of getting the W coordinate right. Placing everything in the back, trick here is to get the Z coordinate set to 0. Because that's the one that controls the depth. So that's the trick as far as that is concerned. I think we're going to have to split the view transform into two parts, a view and a perspective transform. Or a projection transform. Not that I'm entirely happy about that, but I think we'll have to. So that's a little bit of work. So for our camera, we have a transform, we need another transform, we need a projection transform, and a view transform. This projection transform data, because we now have a function called projection transform. So projection transform data, projection transform data. Good stuff. Then I need the camera. Projection transform is just return our projection transform. Now for this, I'd like to start with an identity matrix for our view transform instead. And then just return that. Now that means that a lot of this stuff here, we have a camera matrix with a transform in it. So for our rendering here, we also need to pass in a projection transform, the current projection transform. So yeah, we have all of that set up. Now for our chunk renderer, this is really the, I'm just gonna grab the name of this. There we go. So for our chunk renderer, we just take this in and ignore it for now. Probably gonna get its own material, but right now we have the renderer loading the material used for the chunks, which is far from ideal. And then we're gonna split this up into view matrix and projection matrix. So up here we have our camera matrix, which is going to be the view transform. Okay, because we're calling it matte everywhere, it's going to be projection matte. So that's going to be the projection transform. So we have a constant uniform view transform. We also want a projection transform here that we can bind our projection matrix to here, and we want to bind our view matrix here. So for our material, where is it? I'll grab the view transform, because we're going to get another one called projection transform. And it's going to look for a variable called projection transform. So we have this thing, which grabs the projection transform. There we go. So that sets all of that up. And of course, I need to have a variable here for the uniform projection transform. And in this function, we of course need to check the projection transform and not anything else. Would be unfortunate if we bound the projection and the view transform to the same uniform. So we get that set up. So we need to adjust this thing definitely, because it now also needs to take care of the projection transform. And the thing it does here is it just multiplies it in front. Nice and simple. And for now, we're just going to do the same in our skybox, just so that we don't change anything. So we have an out-of-line definition here for a chunk renderer, because it needs to know about the projection transform as well. Current projection transform. There we go. And for the skybox renderer, we also need the current projection transform here. So skybox renderer.h pulls it in here, as does the function. And we need to bind it as well. So we're going to get the projection transform here, and we're going to give it the current projection transform. So we're linking, we linked. Try and refresh that. So far so good, looks like the same as before. So what we want to do now, this is where it gets interesting, is that we want our skybox renderer here to have zeros at the end here, like that. Because then what we're going to do in our skybox here is that we're going to start by doing this thing. So we multiply our vertex, which has 0 at the end, with our view transform. Thus we ignore the we're ignoring the translation. Then we set a W coordinate to 1, so that we actually have something to perform our projection transform against. So we now perform the projection transform, and then finally we set the Z coordinates to 0, which should put it as far away as possible. And let's see if that works. So again, with this time where you can actually see what's going on. We get our position in here. We have our vertices with 0W. So that means we ignore the translation of the view matrix, we assign that, then we put a W coordinate on it. We then do the projection of that, and then we put Z at 0 so that it's as far away as possible. And that's what's going on. We're going to try that out. Well, I'm definitely only seeing the skybox now. So what if we set the Z coordinate to 1? Just need to clean and then rebuild. Let's see how that looks. Oh, it's behind everything now. Definitely not looking how I wanted it to look. And it's not really respecting what we're looking at, which is a little bit weird. But it's correctly rendering behind everything. So I'm calling that at least a partial success. So you think you were right? Oh, wait. I need to use the geo position so that I'm actually continuing with that. Let's try that again. So we clean, we rebuild, because otherwise I'm just going to be using the, all of this becomes irrelevant. So I'm not even using the view transform, which is why I can't look around at all. So yeah, let's give that a go. So we've built it, switch over, reload. Yeah, that's beautiful again. That's interesting. So what's going on here? Because it's taking the rotation correctly, it looks like. And it's ignoring the translation because it's following us around as we move, which is good. So I'm really wondering about that, and we're going to try and do a little bit of a different syntax. So I'm just going to do vec4 based on the GL. We're going to do a vec3 temp here based on the x, y, and z of this, and then we're going to create a vec4 based on temp and a 1. So we're going to clean it. Oh, it's not like I have any shader errors up here, which is, I guess, good. So, cleaned, we're going to build. Now we're going to jump over here, and linking is done. Nope, no difference. No difference at all. So that's not it. So what happens if we don't set that set coordinate? Gonna try it one more time. Switch over here, refresh. So if I don't set the Z coordinate, I have, well, it's a kind of success. It's now following me around. And when I get close enough to something else, I can see that instead. So that's a positive, I guess. So something's wrong with setting the Z coordinate like that. I want to try and set it to -1 instead. Based on the idea that in the default configuration, you're looking down -Z from 0 to -1. I think it's either that or it's from 1 to -1. So -1 might be the furthest away and 1 might actually be the closest, and it's getting really weird because we're getting into the near clipping plane. I'm guessing, kind of. So I want to try and move it to -1. So now we've got our GL position set to -1 here. So we're going to try that. Nope, that looks like crap again. But it is definitely the closest thing we can get. Time for Google. To kind of die a little bit. There it was. There we go. Try that again. So we want to do an OpenGL cube map skybox. So yeah, creating a cube map, we've got that part down, skybox stuff, loading it, different faces, displaying it. So grab the texture coordinates as the position of the vertex. Oh, so they're doing just completely normal stuff and then messing with the GL position. I still want to ignore that translation here, but the GL position stuff here is actually kind of relevant. So what if we are going to translate that quickly over here? That means that we're going to set the Z to be the same as the W. So GL position. Oh yeah, because it divides out by the W coordinate. Oh yeah, that's why it's like that. So when it's doing the perspective divide afterwards, it divides by the W coordinate, and that might be weird shit because we've done a projection transform. So by setting Z to the same as W, when it does Z divided by W, that gives 1 because they're the same, and that makes it as far away as possible. Wonderful stuff. Let's try that again. So we just do a quick compile here. And reload. Hey, and it works. We've actually got a skybox. So that's a little bit of extra color. So we've been streaming for about an hour now, or an hour and a half. I just want to take a quick 15-minute break, and then we're going to come back, and then we're going to look at putting some grass on some of this so that it looks a little bit more interesting. And yeah, that's the plan for the second half here. But now we're going to take a break until 1:45. Enjoy your break.